Alright, here is part 2 of that review before the corrections. And sorry, we got interrupted for a minute there. So those are the characteristics we're going to have to find for this rational h of x given to us. So the very first thing we always have to do is going to be factor, right? So let's factor that, okay. Look at your greatest common factor in the numerator. Both of those terms have a factor of 5 and both of them have at least an x squared. So we're going to take 5x squared out, factor it out. So this 5x cubed divided by 5x squared will leave me with an x. And then 5x squared divided by 5x squared, remember we talked about that in the part 1, has to be a 1, right? Because 5x squared divided by itself is not 0, it's a 1. So we need that 1 there. Okay. Then we're going to factor this, and again I like to do my little quick trial and error way. So I know I need an x and an x. How do I know that? Because when I multiply the first and the first, I need to get x squared back, right? That's the only way I can get an x squared. And then if I need a negative 7 here, well, that would be, what can you multiply to give you a negative 7? I don't want that there though. That would be a negative 1. I want to end up with a negative 6, so it's going to be a positive 1 and a negative 7, right? Positive 1 times negative 7 is negative 7, and when I add those, I get negative 6, so I'm good to go. Okay, so now that we have that factored, let's see what happens. We have a factor of x plus 1 and a factor of x plus 1, so we already know that there is going to be a whole at x equals negative 1, right? But now we cannot just stop there, because remember a whole needs a y value, right? We need to know how high or low that whole is for the x equals negative 1, right? So we need actually to rewrite that in simpler form. So left over, after we cancel the whole, we would have 5x squared over x minus 7. And when we do that, we're going to say, okay, now we want to plug in a negative 1, so such that x equals negative 1, and what would that give me? That would be 5 times negative 1 squared over the negative 1 and then minus 7, right? So when you do the operation here, that will be equal to negative 1 squared is just a positive 1, right? And then 1 times 5 is 5, and negative 1 minus 7 is negative 8. So the whole will be at the point negative 1, negative 5 over 8, right? 5 over negative 8 is the same thing as negative 5 over 8. This is the location of the whole, so we're done with the whole. Okay, next thing we need is the vertical asymptote, if any. A vertical asymptote, remember, is going to be an x equal, right? So don't just put a number there. Make sure you put x equal. Vertical asymptote are whatever factor with a variable is left in the denominator after the wholes have been cancelled. So we have one factor left here, and that's x minus 7. Therefore, we have a VA at x equals positive 7. The next thing I want is horizontal or slant asymptote. So we have to decide what we are dealing with here. So look at your degree. The degree in the numerator is higher than the degree of the denominator by 1. So I know we have a slant asymptote. Okay, so we're going to have a slant one. And how do we find it? We need to do a long division. Okay, so let's get busy. I need a 5x cubed plus 5x squared. Then I don't have a linear term, and I don't have a constant. So I'm adding those. Those are in the back, so I might not need them, but I'm adding them just in case. I'm going to need at least the linear. Okay, now division. So we're going to do, in our little thinking bubble, we're going to take the first divided by the first. So 5x cubed divided by x squared, and that will give me 5x, right? So I'm going to put that over my linear term here, 5x. And now we're multiplying, right? So what are we multiplying? 5x with the whole trinomial, right? So 5x times x squared is 5x cubed. 5x times negative 6x is negative 30x, and 5x times negative 7x is negative 35x. Okay? Remember, we need to subtract. So 5 minus 5, that goes to 0. I have a 5x squared minus minus becomes plus. So 5x squared plus, oops, did you notice that? I forgot my x squared there. That would be tricky here. That would mess up the whole thing. 5x squared plus 30x squared, that would be a positive 35x squared. And then I have 0x plus 35, so 35x. And then we might not need it, but we're going to put it there. And now I'm going to go 35x squared divided by x squared. So in my thinking bubble, 35x squared divided by x squared is going to be 35. So up here, I'm going to put plus 35. And I'm going to finish my equation, or my division. 35 times negative 6. So 35x squared times negative 6 will be negative 210, right? Yeah, 210. And I want a negative there. And then 35 times negative 7 will be negative, so just one more 35 than that, right? So negative 245. All right, and now we're going to subtract. So that goes to 0. Then the negative here makes that a positive. So 35 plus 210 will give me 245x. And then 0 and then plus, so plus 245. Now, I only wanted the slant asymptote, right? So we understand that this will be all I need, right? So the slant asymptote will be y. Don't forget the y equal, or you won't have the equation of a line. And so remember, what is that telling us? It's telling us that the slant asymptote is going to have a y-intercept of 35 and a positive slope. Therefore, it's going to go that direction, right? Not this one. It's going to go this direction. And so that means that the end behaviors as the limit as x approaches positive infinity would also go to positive infinity. And the limit as my x value would go to negative infinity would also go to negative infinity. I'm going to write that down. So limit as x goes to positive infinity of my function h of x are going to go to positive infinity, and we said the limit as x goes to negative infinity of h of x also, sorry, not also, goes to negative infinity. Okay. So that was for my slant asymptote. We don't have a horizontal. We can never have both, right? You cannot have a horizontal and a slant because that wouldn't make sense, right? The degree here in the numerator has to be greater than the denominator, and that would mean we don't have a horizontal asymptote, right? Okay. Next thing I need are my x-intercept. So remember, x-intercept is whenever we cancel the whole, after we factored and cancel the whole, whatever is left in the numerator becomes your x-intercept. So here we just have a 5x squared left. Therefore, the x-intercept is x equals 0, or we can write it as an ordered pair, right? Then we need to give the y-intercept. The y-intercept is when we substitute a 0, right? Because y-intercept is always when x equals 0. So when you plug in a 0 here everywhere, you would end up with a 0 over negative 7. 0 over negative 7 is 0, but we already knew that because we had it up here, right? So the y-intercept here is at y equals 0, which is the point 0, 0. The next question is, are the x and the y-intercept both at the origin? And the answer would be yes, right? They're both 0, 0. Okay. And then we're going to only give the domain here. The range will be a little tricky because of the slant asymptote, and we haven't talked about that, so we're going to skip that. And we just give the domain. Remember, domain will be the set of all the x's except where there is a hole or a vertical asymptote. So the domain x cannot be, so go back to where we had a hole, -1 for the x value, and go back where we had a vertical asymptote, which was 7. So those are your two restrictions in the domain. Okay, so this one is done. Let's go to the next one. We almost want to say, well, there is nothing to factor here, but is there nothing to factor? Your leading term has a negative here, so you want to go ahead and factor out a negative, which makes that a positive x and that a -3. This is going to be critical when we are going to look for the x-intercept. Because when we look for the x-intercept and we look at that, we want to say it's -3, but it really is not. The x-intercept will be at 3. So it is critical that you do that, right? It's not just for the fun of it. It's actually very critical that if your leading term has a negative, then you need to factor out that negative, okay? There is nothing more we can do here, so we are ready to go. First, is there a hole? So we're going to say no hole, right? Because nothing cancels. And don't you go about and cancel those two x's, right? We cannot cancel when we are not in factored form. This is not factored form, right? This x is tied by a plus or a minus to something else, right? So can't cancel that. So there is no hole. VA, do we have a vertical asymptote? And we sure do. We sure do. Look in your denominator. What is that? That will be at x equals 0, right? So the y-axis here is actually our vertical asymptote. The next thing we have to do is horizontal or slant asymptote. Well, look at your degree. This is linear, therefore the degrees are the same. When the degrees are the same, we want the leading coefficient over the leading coefficient, so -1 over 1, and therefore the horizontal asymptote is at y equals -1. Okay? What do we want next? X-intercept and y-intercept, if possible. So let's go x-intercept first. And the x-intercept would be whatever is left in the numerator as a factor, right? After everything has been cancelled and simplified. X minus 3 is still in my numerator, therefore I have a 0, a root, an x-intercept at x equals 3. So x equals 3. And you can write that as an ordered pair if you want to. The x-intercept are always when the y is 0, right? We should know that it's on the x-axis. All right, y-intercept. Do we have any y-intercept? And the y-intercept is when x equals 0, right? So if that's the case, we're going to plug in the 0. Substitute 0 in for x, so 0, 0. When you do that, you're going to get 0 plus 3 over 0. So that will give you a 0 plus 3 over 0, which is 3 over 0. And can we do that? Don't tell me that's going to be a 0, right? Or don't tell me that's going to be a 3 either. We cannot divide by 0. This is undefined. And we knew that because we had a vertical asymptote at x equals 0. If there is a vertical asymptote at x equals 0, that means on the y-axis, the function never touches. Therefore, we have no y-intercept. There is none. Cannot divide by 0. Okay, be careful on that one. Okay, so are the x and y-intercept both at the origin? Well, obviously they cannot be, right? Because the origin is part of my exclusion. I have a VA there, vertical asymptote, so can't have that. The next thing I need is my domain. Domain, remember, are all your x's you have to exclude will be the holes and the vertical asymptote. Well, there is no hole, but we have a vertical asymptote at 0, so x cannot be 0. All right, that's it for that. Now let's quickly do a little bit on expanding a binomial using Pascal's triangle. So I'm just going to go ahead and do Pascal's triangle. So remember, we start with a triangle of ones, and then we add those two, and centered below them, we're going to put their sum. So 1 plus 1 is 2, and then I'm going to put my ones around it to keep my triangle shape, right? Add those two, the sum goes centered below. 1 plus 2 is 3, 2 plus 1 is 3, and put your ones, and then keep going. Okay, I can stop here because I want to expand this binomial to the fourth power, and that will be this line, the line with the 4 right after the 1, right? So what I want is 1, 4, 6, 4, 1. Those are going to be part of my coefficients for my expansion. And now I'm going to go back to my binomial, and I'm going to say my first term was an x. So I'm going to put an x. But it cannot just be an x, right? We're going to start with the power we're expanding to, so 4, and we're going to count down all the way to 0. Now we can stop here because we have a second term here in that binomial, so we're going to do positive 3. And you're going to say, well, do we need the parentheses? No, we don't, but if this would be negative, we definitely would need it. So I'm just demonstrating that it's probably safer. And then backwards, right here I'm starting with 0 and I'm counting up, and if I do it right, I better end up with the exponent I have for my binomial, right? 4. And now at that point, I'm just going to multiply all of those straight down, and that will be my expansion, right? So 3 to the 0 power is just going to be a 1. So really what I have is 1 times x to the 4th times 1. That will just be x to the 4th. And then here I have 3 to the 1st power times 4. So that will be 12. And then your x cubed. And that's a positive. And then here you're having 3 squared, which is 9. And 9 times 6 is 54. X squared. And it's a positive. Here I have 3 cubed, which is 27, and 27 times 4 will be 108, positive, and that's just x to the 1st power. And then anything to the 0 power goes to 1, so we don't have an x anymore, so 1 times 1 times 3 to the 4th is 81. So the answer to this here will be x to the 4th plus 12x cubed plus 54x squared plus 108x plus 81. Okay? Now going to the next one. Here I'm only asking you for a specific term. I don't expect you to do the full expansion. I just want the fourth term. Okay? So let's look at our expansion, at our binomial here, and this time we go to 6, right? So I need a few more here. So I'm just going to keep going on this triangle I already have, and I need to go all the way to the 6 here. So I'm going to have 5, 10, 10, 5, 1 and 1, and then here it will be 6, and that's the one I want, right? So that will be my last line I need. 5 plus 10 is 15, oops, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and then a 1, right? So I need that line, but I don't want the whole line, so I'm going to recopy that down here just so I can explain. So 1, 6, 15, 20, 15, 6, 1. 1, 2, 3, 4, 5, 6, 7. I have one more than what my exponent is. That's what I expect, right? Because of that 0 we're adding to that. Okay, I only want the fourth term. So first term, second term, third term, fourth term. So whatever I do here, that's the one I'm going to want. Okay, now just like we did up here, we need to look at the first term in the binomial. And so we will have an x here, and an x, and an x, and an x, etc. And I don't need those anymore, right? So I can stop. And I would start with my highest exponent first. 6, 5, 4, 3. I can stop. That's the one I'm interested in. And then I need my second, and here be careful, right? Because it's a negative 2, not a positive 2. So I need negative 2, negative 2, negative 2, negative 2, and we can stop. And this time we're stacking backwards, so I start at 0 and I'm counting up my exponent, and so here I will be at 3. The way you know you did it right is when you add those two exponents, it has to give you back that number, right? Check it up here. If I'm adding 3 plus 1, it will give me the 4 I needed. 2 plus 2, 4. 4 plus 0, 4. 1 plus 3, 4. 0 plus 4, 4, right? So to know that you did it right, if you had a 6 power here, 3 plus 3 is 6, so your exponent at least are correct, right? Now the only thing you need is simplify that for the fourth term of that expansion. Okay, so I have 20 times x cubed times negative 2 cubed. That will be my fourth term. So what would that be equal to? 20 times x cubed. Negative 2 cubed is going to be a negative 8. And now finish it up, right? 20, notice how my parentheses are not a luxury here, because if I wouldn't have them, it would imply a subtraction, right? This is not a subtraction, this is a multiplication, right? So make sure that's there. 20 times a negative 8 will be a negative 160. So negative 160, and then don't forget your variable. And that, ladies and gentlemen, will be the fourth term of the expansion. If you asked for a specific term and what you give is the full expansion, you did not answer what you were asked to give, right? And so you can't expect the person who is reading your paper to make a decision for you on which one it is that you were actually supposed to give, right? You're the one that's supposed to give that. All right, that's it for this review. I hope that was helpful, and I'll see you in class.